Hi everyone. In this video, we will talk about very famous NoSQL database called Apache Cassandra. We will see what are the various constraints when you should use these kind of databases and how data is actually distributed across all the machines in the cluster. So starting with the very formal definition of Apache Cassandra, Cassandra is a distributed, decentralized, highly scalable and highly available NoSQL database. I know these are a lot of terms to digest at one time, so let's take them one by one. By distributed, it means it is capable of running on multiple machines. If you have a large data, growing data, obviously you cannot accommodate all your data on a single machine. That's why the need for the distributed database arises. By decentralized, it means that there is no concept of master slave. All the nodes are equal, they have the same function. If one of the node goes down, the other can easily take its place. And also there is no single point of failure as in master slave. Because in master slave, if one of the nodes goes down, the master goes down, the whole system gets crashed. But here that is not the case. Also because of the same reason, these kind of databases are also highly available databases. So let's talk about the scalability. Scalability means we can add, we can remove any node without restarting any process, without doing any manual intervention. Even we don't need to rebalance any data. All happens behind the scene, behind the background. We just need to configure whatever the node or the machine we need to add or remove. Now we will see what are the various use cases where we can use Cassandra as a database. If your data is large and growing, then obviously you can consider Cassandra as a database, but there are other factors to be considered before using that. Secondly, if high availability is a concern for you, then Cassandra is a highly available database with no single point of failures. The third thing to note is that if consistency is not a concern for your application, so by default Cassandra is eventually consistent. It means if you write something and read something out, it could be possible that the data you read is inconsistent. Though the Cassandra provides the tunable consistency, means you can increase the consistency level, but it comes with the performance impact. So next thing is if you need faster writes than reads, the Cassandra has very high throughput for the faster writes. So all these along with some more factors has to be considered before choosing any distributed data. Scalability always comes with a cost. Like there are few constraints on Cassandra database. If you have heard about relational databases, you know there are joins, there are foreign key relationships, but in Cassandra, there is no concept of joins. There is no foreign key. You cannot refer from one table to another table. You cannot join two tables to derive some other outputs because these kind of operations are very expensive in terms of distributed database. Because of these two reasons, we have to denormalize our table as far as possible. Duplicates will be there because we cannot afford normalization of structure. Now we will see how the data is distributed across the cluster. When we set up nodes in a cluster or when we add or remove some nodes from the cluster, these nodes are being assigned a range of tokens. These tokens are nothing but the hash value generated by a partitioner class. So let's assume for the sake of simplicity, let's assume we have a token range from 1 to 100 and we have 5 nodes in a cluster. Assume these token range are uniformly distributed across the cluster. So node 1 will get 1 to 20 token range, node 2 will get 21 to 40 and so on. And now talk about the primary key of the data that has to be stored. The primary key consists of two parts, partitioner key and clustering key. The partitioner key is responsible to decide how data will be distributed across the cluster and which node will get which data. And the clustering key is responsible to decide how data will be stored on a single machine. So let's say we have a movie table and we want the movies of all the of same actor to go on to same node. Suppose we want the movie of Tom Cruise to go to some node and we want the movie of Tom Hanks to go to some other node. So what will happen? We can take the actor name as the partitioning key. So whenever the partitioner will be applied on the partitioner key, it will give us some token value, and that token value will be mapped to the token range. Suppose the Tom Hanks give us 61, so that will be mapped to the node 4, and the data will always go to the node 4 for the Tom Hanks movie. I hope you understand how the data is distributed. Thank you for watching this video. I'll keep on sharing new technical videos. If you like this video, you can subscribe to me.